Welcome, explorers! Today, we're heading out on a truly cinematic expedition into the wild and fascinating landscape of technology. Now, in this explainer, we aren't just rattling off textbook facts. No way. We're actually going on a design safari to track down the essential survival skills you need for your Grade 7 exam. We'll be moving question by question through our field guide. So, grab your gear and get ready to observe the natural habitat of lines, shapes, and structures.
Here's the agenda for our trek today. 1. Mastering design considerations. 2. The language of graphics. 3. Measurements and scaling secrets. And finally, 4. Bringing drawings to life.
All right, let's dive right into Section 1, Mastering Design Considerations. This is where we explore the absolute foundation of products.
We're starting off with question 16 in our field guide. What does fit for purpose actually mean? Well, out in the wild, a product's survival depends entirely on being fit for its environment. It means the product absolutely fulfills its intended purpose. As a designer, you've constantly got to ask yourself a few things. Who is this for? What is it actually for? Is it safe? And is it cost-effective? And absolutely crucially, how does it affect the environment around it? If a design fails these questions, it simply won't survive. Moving on to question 17. What is ergonomics? Think of this as the way design perfectly adapts to the human form. It refers to the specific features of a product that make it user-friendly, comfortable, and completely safe for the human body. You know when a chair just perfectly supports your back? That is ergonomics in action.
Next up, question 18 asks, what is aesthetics? Simply put, aesthetics are the qualities that make a product look beautiful and attractive. We're talking about vibrant colors, sleek shapes, and intriguing textures. It's kind of like the bright plumage of a tropical bird, designed specifically to catch our eye and draw us in.
Now we're trekking into Section 2, the language of graphics. This is all about communicating without words. Which brings us right to question 19. Why do we use graphical communication instead of words? Think about it for a second. If you want to build a bridge with a team from across the globe, words might completely fail you. So, we use drawings and pictures because they're a universal language. They translate really complex ideas clearly and easily, crossing all those language barriers without making a single sound.
But, this wild graphical universe isn't without order. Question 20 asks, what are drawing conventions? Well, basically, these are the official laws of the jungle. They're the strict rules and line types that absolutely everyone has to follow when making technical drawings. Without these conventions, our carefully planned designs would just be chaotic scribbles.
For question 21, we need to track these elusive line types and their functions. First up are outlines. These are narrow, dark, thick lines used to show the visible edges of an object. Next, we have construction lines, which are narrow, very light lines used as the drawing framework. And remember, they are never erased. Then there's hidden detail. These are thin, dark, dashed lines that reveal the hidden, unseen edges inside an object. And finally, dimension lines. These are narrow lines with sharp arrows that proudly display the measurements, like length, width, and height.
All right, moving on to Section 3, Measurements and Scaling Secrets. This is the math behind the magic. Question 22 asks about the unit of measurement on technological drawings and how we write it. So, here's the golden rule. Everything is measured in millimeters, or mm. But here's the mystery. We literally never write the letters mm on the drawing itself. We only write the number. So if you see a 10 on a blueprint, you just have to know instinctively that it means 10 millimeters.
Let's look at question 23. What two rules must dimension lines follow? These lines have absolute, unwavering laws. First, the two boundary lines must never physically touch the object itself. Second, the dimension line, with its arrows, has to run perfectly parallel to the outline. Total precision is required here.
Question 24 asks, why do we use scale drawings? Well, imagine trying to draw a life-sized elephant, or, on the flip side, a microscopic ant on a standard piece of A4 paper. It's impossible. So we use scaling when objects are simply too large or too small for our paper. Scaling ensures we can capture that massive beast or that tiny bug while keeping every single part in perfect proportion.
So, question 25 asks us to compare the two types of scaling. On one hand, we have upscale, which is enlargement. This is where the drawing is larger than the real object, like a 2-to-1 ratio. We use this to magnify the microscopic world for things like delicate jewelry or tiny electronic components. On the other hand, we have downscale or reduction. Here, the drawing is smaller than the real object, like a 1:2 ratio. This technique allows us to shrink a massive, majestic house, a car, or even a simple bicycle pump, right down to fit perfectly onto our page.
And that brings us to Section 4, bringing drawings to life, going from paper to reality.
Question 26 starts us off. What is a freehand sketch and what is it made with? A freehand sketch is like an untamed, rapid burst of inspiration. It's a rough, quick drawing made using only an HB pencil and paper. No rulers allowed here. It's absolutely the best way to capture an idea the second it flashes through a designer's mind.
Now for question 27. Why is shading used on drawings? Well, shading is a really clever trick of the eye. It's used to take a flat, two-dimensional drawing and make it look three-dimensional. By adding mysterious depths and realistic shadows, the drawing suddenly feels like it has real weight and form. Question 28. What is a 2D working drawing? Think of this as the ultimate blueprint of the ecosystem. It's a highly accurate drawing made with instruments showing only two dimensions. Usually, that's length and height, like a flat front view. Because it strictly follows all those drawing conventions we talked about earlier, any other builder out there can look at this blueprint and recreate the product perfectly. Which means question 29 naturally follows. What does a 3D drawing show? A 3D drawing literally leaps off the page. Instead of just being flat, it captures length, width, or height, and that crucial, magical third dimension, depth. It shows the object exactly as it would look if it were standing right in front of you. For question 30, let's explore the difference between oblique and isometric drawings. First, let's observe the oblique drawing in its natural squared paper habitat. Its front view faces directly forward in its true shape, while its depth lines shoot off at a rigid 45-degree angle. But then we have the isometric drawing. This species lives entirely on a special isometric grid, with all its depths drawn at a distinct 30-degree angle. They are two very different but equally fascinating ways to capture a 3D world on a 2D page.
So, what's the big takeaway here? Well, explorers, we've reached the end of our safari, but your journey is really just beginning. Take a look around you. Every single building you enter, the car you ride in, the phone in your hand right now, all of it started in this exact ecosystem. It all began with the very drawing conventions, scales, and sketches you've just mastered. You now possess the tools that turn your own imagination into reality. The wild landscape of technology is waiting for you. So, what will you design next? Good luck on your exams and keep exploring.